I'm going to introduce my colleague Jay. It's actually one of the most requested topics that we've had for these meetups is around container security, which is not too surprising, really. So we're going to fulfill that today. Big shoes. They're small shoes. Right.
Cool.
And Jay, thank you very much.
Cheers, Nelson. So yeah, good evening, everyone. It's very nice to see all of your amazing smiles right now. I know most of you aren't smiling, so carry on smiling. So with my really creative title, you probably guessed what I'm going to be talking about, as Nelson mentioned, is all about container security. And the key reason, most of the time it's requested is when it comes to Kubernetes, when it comes to containers, it's usually an afterthought. You create your clusters, you spin them up, and when something happens like, oh, we need to start thinking about container security, how do you fix it? So I'm going to be talking through a couple of the key challenges that we face with container security, why we have these security challenges, how do you protect those, or how do you protect our modern workloads, and what role does SUSE play in it in terms of allowing you to have the tools to protect your Kubernetes environments. So let's get going. So I know that's sort of a catfish picture there, but my name is Jain Joseph, so I'm a solutions architect at SUSE. The picture was taken 5 years ago, but I focus on everything cloud native, so all around Kubernetes management, security, observability, all of that great stuff. And quite a lot of the time when I speak to customers or users of Kubernetes, especially around the security topic, what I quite often hear is, hey, we want to spin up our clusters, we want to make it sure it's stable, then start thinking about security as sort of the phase 2. When it comes to the phase 2, quite often you run out of budget, it gets postponed to phase 3, and sometimes the appetite is not there or you don't have the right resources. Or the other thing I quite often hear is, hey, we're running cloud-hosted Kubernetes. They do some sort of level of security, right? Yes, they do. They provide you some level of security, or layer of security, but what happens about your running applications? What happens about your running containers? Do they provide a security layer there? And lastly, or one of the common things, is we do scanning. We scan our images, or we do vulnerability management. But is that enough, right? Kubernetes is a very dynamic environment. Can you just rely on scanning or vulnerability management as a be-all and end-all of container security? And I guess one of the key examples here is, say, for example, you go to your favorite airport. Pick airport. Matt, what would you like? Heathrow. Perfect. You go to Heathrow, and you walk in, and you're about to get in a flight to Barcelona. And you walk in, and you go to your check-in desk, you check your luggage in, they look at your passport, look at your boarding pass, and they have a no-fly list. It's like, oh, you're not on a no-fly list. Off you go. And then you go to your departure security, you walk in, expect there to be some X-ray machines, expect yourselves to be standing there like this, but none of that really happens, right? You go straight to your gate, and again at the gate, they look at your passport, they look at you, see if you're on the no-fly list, and get on the plane. How safe would you feel at that moment in time? It's the same, I know that's a wild scenario example there. Same scenario when it comes to just relying on vulnerability management and checking for, scanning your environment. You need to do that sort of X-ray scanning. You need to see if people are bringing in those sort of harmful objects or processes or network connections into your environment, right? This is why I just wanted to talk to you about Kubernetes security and why it's important to address it from the get-go and never leave it as an afterthought when something does go wrong. By the way, if you have any questions, feel free to ask along the way. We can have an official Q&A at the end as well. So what is the challenges with container security? So containers or Kubernetes and containers are very dynamic. Containers have their own life cycle. They get scheduled, they run, they might get terminated, and they get rescheduled onto a different node with a different IP address. And before you might have a single VM that represents your application, now you might have, say, 20 pods or 50 pods, or however many pods that represent your application or a portion of your application. And quite often what you do is you deploy an application or you deploy your containers, you have them up and running, you spin them down. But it's very easy to get into a scenario where you spin them up and keep them running. And eventually you get to a scenario where you're not really sure as to what's happening within that container. You're not really sure why that's up and running. You're coming back onto that sort of legacy mindset of, hey, that's running, I'm too scared to spin that down. And again, from a security angle, that's a nightmare. You don't really know sure what's running, what connections it's making, who has access to it, etc. And Kubernetes sort of works in a mysterious manner, right? You deploy a container. You say, give it a name, you give it or point it towards a container image, you give it some networking, be it node port, load balancing, whatever it may be, and click deploy. Just a simple example of a container deployment. And if I were to ask any of you right now, how does one container within your environment speak to some other container? What protocols do they use? How often do they communicate? What processes are getting run on it? It's hard to get that information out of the box with Kubernetes. And the key reason for that is we lack the visibility inside of your Kubernetes cluster. So the east to west traffic within your clusters. It's almost like you deploy stuff and you're not really sure as to what connections are being made, what container speaks to some other container. You're not really sure. And that, from a security perspective, can be quite a nightmare. Quite a nightmare? Quite a bit of a nightmare. There you go. And you might think I'm making this up, and to the PME guys, sorry, you've probably seen this page before. But this is a snapshot from SUSE Security, otherwise or previously known as NewVector. And this is my sort of lab environment that I have, right? It's nothing major, it's nothing intensive. The most mission critical application I have in there is Tetris. But, as you can see, it's the spider's web of connections that's been made within your clusters that you're not aware of. You're not aware of the traffic that's happening within there. You're not aware of the connections it's making. Should one pod talk to the other pod? Should it talk externally, right? That's the sort of visibility that you lack out of the box. So what can you do to protect your modern day workloads, right? I'm being quite negative so far, but what can you do to protect them? So start embracing the concept of zero trust. I know Danny touched on this earlier. There are instances where zero trust is a very, very valuable resource and a very valuable methodology. And it's a whole process of not trusting anything. So regardless if it's traffic within your cluster, coming in, going out of your cluster, if it's public cloud, if it's on your own data centers, by not trusting anything from the get-go. They have to earn your trust. Obviously, it is a very big process, but once you get to a good stage, it's a very valid and very powerful method. And you have to reassign your security boundary rather than looking at clusters and how to do that sort of cluster security. You need to reassign your security boundaries to these individual containers. So regardless of if you move your containers from on-prem to the cloud onto edge devices, it becomes its own security boundary, meaning that you have to secure your containers regardless of where they reside and regardless of what cluster, what distribution, what OS it gets run on, it doesn't matter. And you can't, layer 4 security should not be, be all and end all of that either. You can't just rely on looking at those layer 3 and layer 4 headers in the packet to build your security model on. You need to do that sort of layer 7 inspection and detection to see what type of payload it is or what the payload itself is, and see what's transmitting within the environment to create that sort of intelligent decisions as to making sure you're aware of what's happening, the processes, what gets transmitted. Is there any sort of sensitive data that's going out of it? That's why this is all important. And automate everything as possible. Again, one of the key things that the PME guys said, right? Automation is key. This is a very dynamic environment. You can't be there, trying to apply security policies for each and every single container that spins up, right? You'll be there for hours on end. This is where you need to, leverage abstractions and leverage automation to group things together, to say, if things, or every pod within a namespace gets a security policy. So it doesn't mean, if you have 10 pods spinning up, 20 pods spinning up, they get automatically included into a group, which means they inherit the security posture of that group, making it very much more easier to handle security and apply policies to this dynamic environment. I see Nelson prancing around. There you go. So how does SUSE approach container security? SUSE Security is one of our solutions from SUSE, previously known as NewVector. It's all around that Kubernetes security. So I sort of divided it up into sort of two key parts. The first one is supply chain security. So this is all around scanning through, your hosts, your nodes, your platform, your clusters, your containers, your registries, to check for any sort of vulnerabilities, any sort of CVEs. So you're aware of, what exists within the environment, what version is it, what's the remediation, how do you go about fixing it, and what version is it fixed in. So it allows you to see what vulnerabilities exist and how you go about solving them. Same thing with compliance scanning. So this is where we can check against the CIS benchmarks for security. And again, compare your environment against say, things such as GDPR, PCI, NIST, HIPAA, etc., and gives you the ability to generate reports very quickly and very easily based on these compliance standards. Lastly on here is emission control. So emission control is all about setting up those guardrails into your runtime environment. So to say, is it coming from a trusted repository? Does it have, what's the threshold for CVEs? Is it going to a particular namespace? Who's deploying it? So it's setting up guardrails into your runtime environment to ensure only what you want reaches your runtime or reaches production. And what really makes SUSE security unique is that runtime piece. So we continue to scan the runtime for, again, vulnerabilities as well as compliance violations, but we have the patented ability to do deep packet inspection inside of a Kubernetes cluster, and that's what makes us unique. In simple terms, what that means is we have the ability to look at the live network traffic. So things such as threat-based controls, so protect against the knowns. So we're able to look at the live network traffic, see attacks coming in, and take actions in real time. So we leverage threat-based controls, as I mentioned, protecting against the known. But also we have zero trust controls, protecting against the unknown, the anomalous traffic. And again, this is what really makes us unique in this whole space. I will go into all of this in a bit more detail in the coming slides, but any questions so far at all? If you want to make Nelson run, feel free to raise your hand. But great, so I'm going to carry on. So diving a bit more deeper into the supply chain security. So we scan as soon as a developer builds an image, and we're able to scan as part of the pipeline. So we have plugins and integrations into your favorite pipeline tools, so be it Jenkins, Circle CI, Azure DevOps, GitLab, and we can scan as part of the pipeline scanning, which means you can pass a failure build based on your threshold for vulnerabilities. And once you go through that sort of build phase and put your images into your registries, be it public, be it private, we can scan there as well, since what's safe today might not be safe tomorrow. So it's important to keep scanning your repositories, scanning your images to ensure they are in a good enough state for you to deploy into that runtime piece. And mission control, and that's all the important bridge between your CI/CD pipeline and your runtime environment. Since you're able to link your registry scan results to your mission control to say, the image has been scanned, is it coming from a trusted repository? Does it have a CVE? Does it match a particular label? Does it have an OS? There's a whole bunch of criteria that you can choose from. So essentially, you can create this sort of golden standard as to how an image should be and where it should be deployed to within your environment. And once it's in the runtime, as mentioned, we continue to scan for vulnerabilities, compliance violations, check against the CIS benchmarks for security to ensure you're aware of what's happening within your environment and what are the steps that you need to make it better. But as I mentioned, we simply don't stop there. So diving a bit more deeper into that runtime security. So first, threat-based controls. So again, we check for the vulnerabilities, those CVEs. And it's not just the SUSE database that we scan for. We scan across 17/18 different databases to ensure that you have all of that latest CVEs. And we update that CVE database on a daily basis. So again, you have the most up-to-date vulnerabilities that you're scanning your environment against. We can also do container DOP, so container data loss prevention. So this is where we check every single container connection for sensitive data leakage. It could be credit card information, financial data, personal information, whatever is sensitive towards your business. And as I mentioned earlier, we can protect against those network attacks. We can see it in real time. We can see stuff coming in, which means things such as, for example, SQL injection, data stealing. We're able to identify that automatically and block it in real time. I won't go too much into mission control again, essentially guardrails for your runtime environment. Next, we have the SUSE security zero trust controls. So we automatically learn the behavior of your application, your clusters, your nodes, your Kubernetes environment. And this is where we learn the network, the processes, the file access behaviors of your clusters, of your containers, and create that security policies around that particular behavior. So we're able to create that zero trust segmentation or the zero trust bubble around your normal behavior. So anything outside of that, we can block, we can alert you, we can packet capture, or we can quarantine a container. Again, very unique to a Kubernetes environment. You might be thinking, hey, why is that important? And those of us who have played around with Kubernetes, I presume a lot of you have, Kubernetes likes to self-heal itself. So for example, you see a problem within your deployment, you try to spin down a particular pod, eventually you might try and spin it back up again, all right? And if that's a security issue, you're killing the pod, it's spinning back up, and you're back to the same problem. And when you quarantine a node, or quarantine a pod, you're essentially not killing it or terminating it, you're essentially restricting any sort of inbound or outbound traffic from happening, allowing you time to go ahead and investigate that issue and solve it, but also allowing you time to make sure that container does not infect any other containers within your environment. So we're able to create that sort of tailor-made behavior to say, this is how your application is behaving, this is its normal behavior, anything outside of that, protect me. And this can be quite granular. You can do it on your node level, cluster level, namespace level, or it could be on a per container basis. And the key thing here is we can even export that behavior as code. So security as code, which means you can take it from one environment and replicate that across other different environments running your application. And again, very important if you're moving from your development environment to pre-prod to production, you can start doing all of the learning and development, and you have your golden sort of standard of how my application should behave. Export that and import that into pre-production and deploy your application. And from the get-go, your application is protected. And again, move that across to production. Deploy that security as code, deploy your application. Again, it's protected from the get-go. And last thing on here is we have 3 different modes to enable this sort of zero trust. One is discovery mode. This is where we learn the behavior of your environment. Then we have monitor mode, which is essentially alerting you on any sort of anomalous behavior. Lastly, we have protect mode, which is blocking that sort of anomalous or unknown behavior, which means you don't have to stick everything into block or protect. You can keep stuff in monitor. Like Danny said, people make mistakes, people want to learn. So it's fine to put stuff in discovery or monitor mode, let them learn, and let them see what's allowed, what's not. But for your most mission critical stuff, you can put them into protect mode to ensure they get blocked and they're not affecting your day-to-day business or day-to-day operations. I think I pretty much summed this up in the last slide, but essentially we give you back the visibility into the Kubernetes cluster. As I showed you with the snapshot earlier on, we're able to visualize, but also give you all of the network connections it's making. What protocols are they using? How are they communicating? Should they be communicating with each other? Should it be talking externally? So you're able to make more intelligent security decisions and policies based on what you see, rather than just creating generic policies. And again, zero trust is a key reason we can protect against that sort of 0-day attacks or unknown or unpatched CVEs. You're able to say anything outside of this bubble, outside of my segmentation, protect me, block it, alert it, etc. But that's SUSE security, right? But security and SUSE doesn't really stop there. There's a whole, quite a number of layers that we have to protect in order to protect your cloud native environments. So the 4 C's of container security, we have code, we have container, cluster, and cloud. And I mentioned cloud at the start when we were talking about hosted Kubernetes and saying, hey, will they provide you with a layer of security? They do. But what happens about the application layer? And this is where things such as SUSE security comes in very useful. It could be on-prem, it could be in your cloud environment, is agnostic to the Kubernetes distribution, which means you can protect your applications in the cloud. Let the cloud providers provide you with all of the security to protect your infrastructure, to protect environment. Let SUSE security protect your applications. But also, when we're talking about infrastructure, we have SUSE Linux Micro. As you know, we are quite a famous Linux company. Probably 33 years ago, we were the first marketed Linux distribution. And with that, we have a lot of experience when it comes to creating operating systems, especially Linux ones. And SUSE Linux Enterprise, or SUSE Linux Micro, is a very reliable, lightweight, and secure OS that's purpose-built for containers and virtualized workloads. And it sort of inherits all of the security posture, so all of the security hardening and compliance components from SUSE Linux Enterprise. So it has that strong security posture from the get-go. So it's very lightweight, it's secure by default, which means you're building on top of a very secure and a strong foundation on top of which you can run your Kubernetes, on top of which you can run your containers. But again, that foundation layer doesn't stop there. We have SUSE Rancher Kubernetes Engine 2, otherwise known as SUSE RKE2. this is pretty much an enterprise-grade Kubernetes distribution, focused and optimized for security. So again, let me do the click of button. So as I mentioned, it's focused and optimized for security. So a couple of key examples here. We're able to pass through the CIS benchmarks for security with minimal operator intervention, as well as you're able to enable FIPS 140-2 on it. And we continually scan for any sort of vulnerabilities, for any sort of issues with this Kubernetes distribution to ensure that the users of it, our customers, are having a very secure experience, a very stable experience when it comes to them running their applications on a Kubernetes distribution. Container. So SUSE Linux-based container image. Can I get a very quick hands up of anyone that's heard of that? It's almost like you work for SUSE. So essentially, it is our base container image. And again, you probably see where this is going, right? It inherits the security posture of SUSE Linux Enterprise, which means you're able to build your container images with a strong and secure base OS. So you're able to build your images based on SUSE Linux container image. Again, it's open to everyone. Feel free to go and use it. Highly encourage you to take a look. But those of us who have heard about the Rancher or SUSE Rancher Prime application collection, it uses the SUSE Linux-based container, or SUSE Linux BCI is a long word to say keep. But yeah, it uses our internal application collection, uses that base OS. And if you check the SUSE Rancher Prime application collection, just pick any application from there, be it Argo CD, be it Prometheus, and compare it to upstream, and you will see the difference in the CVEs, the vulnerabilities that exist within it. We aim to give you 0 critical vulnerabilities when it comes to the Rancher Prime application collection. And code. I probably mentioned this quite a lot. We're able to secure that container image or your container lifecycle from the moment you create it within your container image to the moment you run it. We're able to scan your code, scan through the Docker file to essentially ensure what you have put together is as safe as possible. Are you using vulnerable packages? What about compliance? Are you going against any sort of best practices? Are you going against any sort of GDPR violations, HIPAA violations, etc.? So you're building an environment that's secure from the get-go when you're creating the image, when you put it into your repository, and when you're running it. And I'm going to put like a very nice blue outline around that to say, that's it. That's it from me for today. But essentially, SUSE security is our solution for securing the Kubernetes layer. But security and SUSE go way deeper into the infrastructure, into the cluster, into the container, into the code. And if you do have any questions right now, feel free to ask me. Or if you want to see this in action, rather than me presenting slides and saying it works, if you want to actually see it working, feel free to come to me, at any of these tables or chairs. I'll be happy to show you a demo or anything to do with this. But if I were to say, one thing to take away from today is please, please, please start thinking about security as soon as you start thinking about containers and Kubernetes, right? Since it's much easier to do the work now rather than wait for something to start happening, right? By that time, you'll be under a lot of pressure. You'll be trying to implement as many tools as possible. So rather just do the steps early as possible so you have an easier journey and allows you to strategize what's the best for your environment. So with that being said, I think I'm nearly out of time. Thank you very much, everyone, for listening. Is there any questions?
Just quickly, you touched on. Just quickly, you touched on obviously the developer side and sort of the vulnerability scanning and the scanning are there, and obviously I'm guessing that kind of includes static code analysis.
Yes. So what we do there is essentially check through. For example, when you create a container image, you have your Docker file, right? So what we can check through is check through your packages and see, okay, what sort of vulnerabilities exist within those packages that you have. So when you go through, for example, with Jenkins, you do that sort of build phase and you put it into your registry. So as part of the build phase scanning, we can go through each of those layers within your container image and say, hey, does that layer have a vulnerability? What happens if you change that bit of code around so it's according to the best practices? So there's less going on saying, what is the best way to create an image, but what's the most secure way to create an image, if that sort of makes sense.
Yeah. So do you rely just purely on that, or do you like integrate with linters or anything like that from a development sort of point of view?
So within SUSE security, it's basically that. This is our own mechanism to do that sort of piece. But you know, it's that sort of open source world that we live in. So you know, if you do want to use other tools and stuff, absolutely fine. So with SUSE security, it's not the case of you have to use this and nothing else. It works really well with other solutions as well. So you can use bits that you're familiar with. So other people might use some scanning tools that they're happy with. Keep that and just use SUSE security for more of the runtime piece. So it's just about finding the right balance of what you're comfortable with and what you want out of the solution.
Okay.
Yeah. There you go.
So from a platform point of view, if we're providing this to tenants, is the like SUSE security application kind of, you know, ready for end users? As in, like, you know, they're kind of not necessarily developing through, they're deploying applications. And like how much, so is it ready for kind of those users to come and just use it, see what the security cluster application is, and how much of a service wrap have you seen other enterprises kind of putting around it before they hand it over to end users?
Sure, yeah. So I'll probably go through the user side first, right? So as mentioned, with this, you can put it into different modes. So you have your discovery mode, monitor mode, protect mode. So what most of the time people do is say, you know, tell the developers or tell the application teams to say, you know, run your application on this cluster within your development environment. Let NewVector or let SUSE Security pick up on all of that information. After that, you can decide, you know, should, you know, such a process such as ls, for example, just random process, should that be allowed as part of that image running process? Or should this connection be made? So as part of that sort of discovery work, they're not having to do all of that work from the get-go to identify how their application should behave. It's able to do all of that work there. Then you can make that decision to say, filter out a couple of these processes, filter out a couple of these connections or file access behaviors. And after that, they can move into that sort of pre-production mode where they put it into monitor mode. So monitor mode will essentially not block any sort of behavior, but will alert you on any sort of anomalous behavior. So they do the discovery, they run it in pre-production, and you run it for a while. And you see, okay, it seems to be sticking to its normal behavior, and you're able to see if there's any sort of anomalous behavior. If you see that, you can omit that as an allowed or user-created behavior, which means you're happy with that to occur on this container going forwards. But again, when it comes to protect mode, obviously that blocks it. So it's that about the staging of that sort of development process to say, do it in development, let those different teams come in and have different actions on them, you know, try different ways in which you create your image and see what vulnerabilities or what processes get run on it. Afterwards, move into more of a standardized manner of this is how my application should live. I guess the second bit around wrapping around that sort of the security teams over to the user teams. So quite often within SUSE security, you have this idea of federated management, which means you have multiple clusters and one of them becomes that sort of primary cluster, and you can cascade down rules across them. And the key thing with this is you can cascade down almost like a golden policies of how your environment should be, like, you know, what images should be allowed to be deployed, you know, what process should be allowed to get run as default. So you can give your users their own clusters, but those golden policies will also exist in order to protect your environment against anything that's outside of the ordinary. And from there, on each individual clusters, you deploy SUSE security on a per cluster basis. So on each individual clusters, what you can do is let the users, you know, users can have different roles within them, but depending on the user, depending on the privileges, you can allow them to do different things. And the key thing here is, say, for example, if you are a platform team or if you're only interested in the cluster and not really worried about security, all of that sort of overview information is provided within Rancher Prime. So you don't even have to go into the SUSE security solution. You can just view that from a nice little bar to say, this is my most affected pod, go ahead and redeploy it. Does that sort of answer the question there?
Yeah, it does. And additional one is, so if we had like a rancher per tenant thing, can we federate that then like through SUSE observability or something like that to a like central place? If we had like, you know, 20 ranchers running for 20 different tenants, isn't
Yeah,
possible to
yeah.
pass the new vector
So
data through.
as I mentioned, like a new vector gets deployed on a per cluster basis.
Yeah.
So you have a new, SUSE security gets deployed onto
I
nearly got kicked out there. You deploy SUSE security on a per cluster basis, so you can run that across clusters managed by Rancher.
Yeah.
It could be multiple different distributions across multiple different Rancher management servers. That's absolutely fine. The federation happens on more like a SUSE security layer, so it's not really tied into SUSE Rancher as that sort of federated
Got it,
environment. It's done through the security. It's done through the SUSE security solution itself.
Cool.
So you can have multiple environments: your dev environment, your pre-production, different departments, all feeding off a single federated environment as well.
Cool. Thank you very much.
No worries. Any other questions about Rancher, SUSE, Life, anything?
I've got one thing to add. There's really exciting news today. So we've just released a new version of RKE2, or Rancher Kubernetes Engine 2, and it's been released today with 0 vulnerabilities from day one, which is really, really impressive for our build teams. Obviously, they did say tomorrow there'll probably be 20, but today, which is a major achievement to our engineers, so I'm quite proud of that one. But thank you very much, Jay.
I'm guessing there's no more questions, right? Oh,
Just not a question, more. Sorry. Thank you, Nelson. Always got to get a word in somewhere. Not so much a question as an observation, and please correct me if I misunderstand this,
Sure.
as you know. So, I'm also, full transparency, I am a SUSE employee. And when I've been looking at SUSE security, nearly fell down the hole, one of the things that struck me was what you just said, Nelson, which is that the number of CVEs that are out there with no solution. So it was just simple stuff, just demo stuff. And you could still find 20 odd CVEs out there, some of them not very serious, but they're vulnerabilities. And there's no patches for them yet, or they haven't been patched for a while. It's quite remarkable amount of stuff that's out there. And SUSE Security is very good at picking all of that up in terms of highlighting that it's there, but as Jay mentioned, the automated discovery stuff covers you for those instances where there isn't a solution, there isn't a patch that you can apply, but SUSE Security can handle it for you because it learns how your application behaves and what's normal, that kind of thing. So, just that really. Thank you.
awesome.
Thank you, Jay.
Thank you very much.